This video is about a couple of sample problems related to the practice problems that I posted for you to work on before you take the quiz. So far, before you take the quiz, I posted one assignment. I'm going to post another assignment where you have to do problems like these. So in this problem, we've got a sample of sulfur dioxide occupying a volume of 652 milliliters at 40 degrees C and 720 millimeters of mercury. What volume will the sulfur dioxide occupy at STP? So the way you handle these kind of problems is you make a little chart. Volume 1, volume 2, pressure 1, pressure 2, temperature 1, temperature 2. I'm going to work it two ways. You can use whichever way you're more comfortable with. For both techniques, though, you have to make this little table. So our volume 1 is a 652 milliliters right here. So 652 milliliters. We don't know what volume 2 is going to be, so put a question mark. Pressure 1 is 720 millimeters of mercury. So you need to go back and watch the pressure video if that doesn't make sense to you. I did a little presentation about units of pressure and also one about units of temperature. So go back and review those videos. Temperature 1 is 40 degrees C. All right, the problem says to go to standard conditions. That's what STP stands for, standard temperature and pressure. So I'm going to put standards up here just as a way of review. This is also in the video. So for pressure, standard pressure is 1 atmosphere. Or you can say it is 760 millimeters of mercury. That means the same thing with different units, just like 12 inches is 1 foot. Or pressure is 101.3 kilopascals. In the video that I made about this, I started by saying that pressure was in PSI most commonly in our everyday world in the United States. So it's 14.7 is standard. These all mean the same thing. That's standard pressure. Standard temperature is 0 degrees C, 273 degrees Kelvin. On a Fahrenheit scale, it would be 32. But we won't worry about the Fahrenheit scale. You will need to know these for standards, for temperature. All right, so those are our standards. Now, 40 degrees C needs to be converted into Kelvin. So let's go ahead and just do that. We had 273. So 40 plus 273 is 313. All right, now we have our first temperatures, our second first temperature and our first pressure. Our second pressure is standard pressure, which we said over here is 760 millimeters of mercury. It's really all of these, but since this is in millimeters of mercury, you want to use the units that are the same. So 760 is standard pressure in millimeters of mercury. We'll also need to go to standard temperature. Standard temperature is 273 Kelvin. In gas law problems, all the temperatures have to be in Kelvin. All right, two ways to do these problems. Way number one, you take your 652 milliliters. We know that the pressure is going from 720 to 760. So that means pressure is going up. If pressure goes up, in the videos that I did, you saw that the volume will decrease. So pressure up, volume down. I would need to multiply by 720 over 760 to make this volume get smaller. And then the temperature is going down. It goes from 313 to 273. So as temperature goes down, that would make the volume get smaller. So I need to make this number get smaller. I could either multiply by 273 over 313 or 313 over 273. But the 273 over 313 makes it get smaller. Since this ratio is less than 1, it makes the volume get smaller. Since this ratio is less than 1, it makes the volume get smaller. If I had flipped the ratios, it would make these numbers bigger, but our changes told us that the numbers are supposed to get smaller. All right, so if we go ahead and work through this, we're going to have 652 multiplied by 720 multiplied by 273, and that's the top. Then we're going to divide by everything else on the bottom. So divided by 760, and divided again by 313. So our final answer is 538.7. We'll just call it 539. All right, so that's one way to do the problem. The second way to do the problem is to use a formula. So I'm going to show you again what I showed you in the video. You see, this was volume 1. Put it in a different color so I can see it. So volume 1. And 720 is pressure 1. 273 was temperature 2. 539 was volume 2. That's what we were looking for. That's 539 milliliters. All right, the 760 was pressure 2, and temperature, the 313 was temperature 1. So now we have this equation, just writing it in with variables. V1, P1, T2 equals V2, and then, oh, I forgot, on the bottom we have the P2 and the T1. So you often will see this formula written so that all the ones are on one side and all the twos are on the other side. So if I wanted to do that, if I multiply both sides by P2, they'd cancel over here. So now I would have V1, P1, T2 divided by T1 equals V2, P2. And then to get the other two over here, I would divide both sides by T2. So they'd cancel here. So I'd have V1, P1 over T1 equals V2, P2 over T2. And that's probably if you Google this kind of problem, this is what you'll see most often on the internet, this form. Sometimes I think it's simpler to multiply both sides by T1 here and here. So then you would have V1, P1 equals V2, P2, T1 over T2. Then multiply by T2. They cancel over here. So now you got V1, P1, T2 equals V2, P2, T1. All right, so I'm going to put a box around this part of that formula or this formula, and you can use it in either form to solve this question. So now I'm going to take the second box here, put it up here. So V1, P1, T2 equals V2, P2, T1. All right, now we can just plug the numbers in. So V1, 652. P1, 720. I'm leaving units off for the sake of room here. T2, 273 equals V2, we don't know. P2 was 760. And T1 is 313. All right, so let's do the algebra on this. So you would multiply these three numbers. You'd multiply these two numbers. I'm going to go ahead and do that. So 650 times 720 times 273 is a big number. So I'm going to use all these digits and round at the end. So 1, 2, 7, 7, 6, 4, 0, 0, 0 equals V2, and then 760 times 313 is 237880. All right, now to do the algebra on this, how do you solve for V2? It's just like solving for x. You divide both sides by 237880. 880. All right, so this cancels that. So I'm going to have this big number, 127764000 divided by 237880 equals 537. Okay, V2 equals 537. Now it's a slightly different answer than I got here. So somewhere there's a rounding issue or I punched a number in wrong, but I don't want to remake the whole video. So you can see the format, and these numbers are close enough that the issue is most likely a simple mistake somewhere or a rounding error. All right, so I'm going to stop it there, and I'll post this one. That gives you an idea how to do the math. You can either use this technique, which I like a little better because it makes you think more, or use the formula, which also works, and these formulas are the same, just rearranged algebraically.